revision session for quiz 2. Yeah, we'll wait for around 5 minutes for everyone to join, then we'll start today's session.
Okay, ma'am.
And also, if you have any doubts in any of the practice assignment or grade assignment, you can ask from week 5 to week 8. And how is your preparation for quiz 2 going?
Ma'am, good.
Okay.
Ma'am, it will be on only from week 5 to week 8 now.
Yeah, quiz 2 portion is from week 5 to 8.
Okay.
So, week 5, you will be seeing superposition principle, then linear electrical components, serial and parallel resistive networks. Then in week 6, questions related to amplifier, power convention, then RC step response. Then the next week is filters, low pass, high pass, band pass filters. Then week 8, you will be solving problems from these, right?
Yes.
So today we will be seeing revision of these 4 weeks, but mostly we'll be covering superposition principle, power convention. Yeah, questions related to amplifiers, filters also we'll try to see. Okay. So this is the first question.
Okay, ma'am. Solving.
Yeah. So they are given Vx as 6 volts. You have to find solve for R. Yeah, try doing it by yourself.
Ma'am, I think its answer will be 50 ohm.
Yes, 50 ohm. 50 ohm is right. Others also try solving and tell me whether you're getting the same answer. So what is the formula for this? If this is R1, this is V1, this is R2, this is V2, this is Rx, and this is Vx. What is the formula for Vx? It is 1 by R1 divided by 1 by Rx plus 1 by R1 plus 1 by R2, the whole of V1 plus again 1 by R2, 1 by Rx plus 1 by R1 plus 1 by R2, V2, right? You guys remember this formula?
Yes.
Yeah, the formula is right, no? So it's basically 1 by 100 divided by 1 by 100 plus 1 by 100 plus 1 by R into V1. V1 is nothing but 16. So Vx is 6 volts. So this is 1 by R divided by 2 by 100 plus 1 by R into 4. So if you solve for R, you will get the answer, right? And the answer is R is equal to 50 ohms. Calculations you can do, right? Shall we move to the next question?
Yes, ma'am.
So that is a circuit where you have to find the value of VA. Yeah, you can use any method. Find the value of VA, but make it fast. So what is the value of VA? Yeah, 7.5 volts is right. Everyone try finding.
Yes, ma'am, doing.
So today we will have this revision session. Then Friday also there will be another revision session. Then Saturday we will have mock discussion. Okay?
Okay, ma'am.
Yeah. So what are the methods we can use to solve this problem?
And
One.
superposition principle.
Yeah, superposition principle is one. Then, so you can try superposition also, but there is another one way, right? See, there are four current sources in parallel. I will redraw this as, so there is a 1 ampere, 2 ampere going upward, 3 ampere coming down, 4 ampere going up. And there are two resistors in parallel. Now these both are the same circuits, right?
Yes, ma'am.
Now, what I will do this is I will apply KCL and find what is the current flowing here. What is the current flowing here? So at this node I will apply.
2 ampere.
Yes. So one is coming out, two is going in. So one will be coming in. Then here also same. So it will be basically 2 amperes connected to 10 ohms and 6 ohms. Now I want to find the current through the 10 ohms, right? Then only I can apply Ohm's law. IR to find VA. So VA is nothing but 10 ohms into I, current flowing through the 10 ohms. Then what is the current flowing through the 10 ohms? How can I find it? Shall I use current division rule? So I will take the opposite branch 6 by 10 plus 6 into 2. 6 by 16 into 2. 3 2s are 6, 8 2s are 16. So it is basically 3 by 4. So 3 by 4 into 10. It's 30 by 4. 7 4s are 20. So it's 7.5 volts. Right? Just because only superposition is there, don't always think about superposition. Try finding the easiest way to solve the problem. Okay?
Okay, ma'am.
Yeah. So this is one question. So there is a circuit given. You have to find these 5 questions. That is, you have to find Vx. Then you have to find current I1. Then current I2. Then, so this is the circuit one. If the voltage source and the current sources are doubled, then you have to find the new Vx.
Okay, ma'am. Doing. One second.
So yeah, try solving. You can either put the answer in the chat box or you can tell also.
I'm done.
Yeah, Vx is 9 volts, right?
Yes, it is 9 volt. I1. I1
Mm.
is 1.33 ampere.
Yes,
And I2 is 1.66 ampere.
yes,
And Vx new 1 is 18
um,
volts.
yes, 18 volts.
And new 2 is 4.5 volts.
Yes, right. Others also try solving. We'll wait for 5 more minutes, then we will solve this together. Yeah, how did you solve? We can use superposition principle, right? So one circuit is 5 volt. The current source I will de-energize it. So I'm opening it. So how will you do the superposition principle? First, we'll identify the number of sources, voltage source and current source. Here it is 3. So first step is I will
Ma'am,
energize.
we can use superposition, but here is one.
You can use. Can you please repeat again? Yeah, was someone telling something?
Yeah, ma'am, my network issue. I am telling about that. Ma'am, here is a ground, na, ma'am. We can use the superposition here also.
Yeah.
Okay.
Every circuit will have a ground, right?
Okay. But when
So
I
you
saw
thought there is
that
a
type
ground.
of
You
symbols,
use.
then feel little bit confusion. Like
Okay, yeah, here you can use KCL, right? Yeah, mesh nodal analysis also you can perform. The
okay.
thing is, any circuit you can use any method. The same circuit you can use mesh analysis, nodal analysis, superposition principle, any other
Okay.
method also. So here I
3
have
ohm and 3
energized
ohm
only the 5 volt, yeah, and
connected
I've
in
been,
series.
yeah,
But ma'am, it is short circuited due to 1 volt
yes.
is
So the current will here will be
0.
0. Then my next circuit will be like this. So basically, where how will be the current flow?
Current equally divides in both resistors.
I'll take another. Yeah, the current will go in this way, then it will return back. The same way, the current will flow in this direction. Since this part is a short circuit, it will come back. So this resistor, there will be no current flow.
Yes, ma'am. They both resistors connected in parallel. Maybe.
Yes.
Okay.
So see this node.
Yes.
Let me mark it as A, and these two nodes are same node, right? B,
Yes. Yes. Yes.
B.
Yes.
So these two resistors are connected in between A and B. Then to de-energize this one, yeah.
1 ohm is in series with it. Okay.
So here also you can find the voltage and you can find the current. Then you can add the current from all the 3 cases. Then you will get the answer for
Yes.
first 3 1. Then for the fourth question, you can change the voltage, right? Change every values of the current source and voltage source. Like that also you can find. Anyway, I'll give you the answer. This is 9 volts, right? Am I right?
Yes. Yes.
Then the next one is 1.33, then 1.66. As someone told, this is right. It is 18 volts, and this is 4.5 volts. Yes. Now, from the answer of the first question, fourth question, and fifth question, what did we observe? For this circuit, my node Vx is 9 volts. All the current, see, the resistors are remaining the same. The
Yeah.
voltage source
When we just double the values, then we also get the double of that
double
answer.
that of the Vx, right? 18 volts. Now,
Yes.
when this is halved, the 9 volt is also half,
Half.
right?
Yes.
Because the circuit is linear.
Yes, ma'am. And we just change the value with doubling it.
Exactly. So you're able to
Yes.
understand the point here, right?
Yes, ma'am. So it is because the same circuit and the value we got from the half of the value, then
Mm,
we know the what is the double of that value.
mm. But the condition here is all the voltage source and current source has to be doubled. Okay.
Double. Yes. And ma'am, about resistors, a resistor did not do anything here.
No, the resistor is actually a like
Yes. What
so
value of the resistance is same
this
there?
resistor network will be some value. So this is the voltage, this is the current.
Yes.
E is equal to IR, right? So if
Yes.
I am doubling voltage, my resistor will be fixed. So my I will also be changing.
Yes. Okay.
So this is to make you familiarize with superposition principle, then linearity.
Yes, ma'am.
Then try solving this problem. This is also another important topic.
Okay, ma'am.
So basically today you will have class from 6 to 7, okay?
Okay. But ma'am,
Okay,
in
ma'am.
If you
given
have
that,
any doubts, yeah, please repeat. Yeah, what happened?
yeah, in calendar given that 6 to 8.
Yeah, if you have any doubts, I will help you with those
We'll raise the
questions.
time. Okay. Okay.
Hmm. Since we have revision session in the next class, Friday and Saturday also, so yeah, what is the answer for the first part? Power absorbed by the 2 volt source?
Ma'am,
Is
10
it
watts.
is it minus 10 watt?
Yeah, it's minus 10 watts.
Minus 10 hours.
Minus 10 watts. Okay. Absorb.
The next one, power absorbed by the 6 ampere source.
And plus 12 watt.
Yeah, plus 12 volt. Right.
Yes.
Then power absorbed by the 3 volt source.
Minus 3 watt.
Minus 3 volt. Then the power absorbed by the 1 ampere source.
Plus 1 watt.
Yes. So we'll just use KCL at this point to find the current flowing in this branch, right?
Ma'am, across 3 volt, can you explain once?
Yeah, 1 second. I'll explain one by one, okay?
Okay.
So first I will use KCL to find the current in this branch. So
Yes.
here it is 6 ampere. In this 1
Ampere
ampere is
opposite.
LV. So it will be 5 amperes, right?
5 ampere. Yes. P is equals to IV.
So we have found. I'll just redraw it neatly here. So this is 6 ampere, this is 1 ampere, and the current flowing here is 5 ampere,
Yes.
and it is 2 volts. Then
Power
this
is
is the,
equals to IV.
yeah.
Then
Then
we
to
have
find the voltage
10.
drop across the current sources, I will use KVL. So if this is the, then it will be like this, 2 volts, right?
Yes.
Please
And
be
3
mindful.
volts also, ma'am. 3 volts also coming off.
3 volts also coming.
Yes.
Yeah, no. That 3 volts you will use for this loop, right?
Okay. We
So
go through
I
loop
know here
wise.
it is already 2 volts. Here it is 3 volts. Then what about here?
Here.
1 volt. See, it is 3 volts here. Okay, first I will see this one. It is 2 volts here. I will take only the first loop. This is 6 ampere. If I apply KVL inside, if this one is delivering 2 volts, then it has to drop 2 volts, right?
Yes.
So I will just so it is the voltage is dropping here. So I'll put this convention and I'll write 2 volts. Okay.
Minus 2. We giving 3
Yeah,
volts,
you
so
write,
it will be 1 volt.
it will be 1 volt. So
Yes.
this one in this orientation is 2 volt. Here the main thing is marking this plus and minus. Right?
Yes. Yes.
Now here if the what is the power VI, it is 10 watts. Is it delivered or observed? The voltage source is giving out the current. So it is
Yes.
delivered.
Delivered.
Now what about the 6 ampere? The current is entering the plus terminal. So it is absorbed.
Absorb.
The power is equal to 6 to the 12 watts. Then what
Yes.
about this one? 1 ampere is coming out of the positive terminal. So power is
I
equal to
do
3 watts
3 volts. Yes.
delivering. Then this one, the current is entering the positive terminal. So it is 1 watts absorbed.
3 volts. Yes.
So basically the voltage sources are delivering power, delivering current, and delivering power, and the current source are absorbing. Okay. So now first I
Absorb from positive and delivers from negative.
yeah, 2 volt actually delivering. In the question they are asking observing, so it is minus 10 watts.
Okay.
Then the power absorbed by the 6 ampere, it is actually observing. In the question also they are asking observed, so it is plus 12 watts, right?
Yes. Yes.
The power absorbed by the 3 volt, but it is actually delivering, so it is minus 3 watts.
3 watts.
The power absorbed by the 1 ampere, actually it is observing, so it is plus 1 watts.
Yes.
Right?
Yes.
Do anyone have any doubt in this question?
Yes. Can you please explain the potential
Sign
above that?
marking, right?
No. The 2 volts. So let's say you started with the left loop. Let's say if we start with the right loop and do a
Yeah, we'll
KVL.
start with
Yeah.
left loop.
Yeah.
The reason why I started with the left loop, okay, see what happens if I go through the right loop.
Yeah.
So I'll mark the direction plus minus. But here there are two unknowns, right? So my 3 volt
Oh,
is
okay.
equal to voltage across the 6 ampere plus the voltage across the 1 ampere. And I don't know
Right.
both values. So I'll again go to this one.
Okay.
Is it clear now?
Yeah. Yeah.
Okay. Shall we move to the next question? Or do you want a little time to go through this question?
No, ma'am. Only please explain the signs absorbing and delivering
Yeah.
after at the ending of the session. It will be-
If there is a voltage source, current is flowing in this direction, and the voltage is here, no? How will you mark the direction for the volt? Will you mark it as like this or like this?
First
Is it
one,
one
ma'am.
or both?
Plus and
First one,
minus.
right?
Yes.
The exact same thing I will do with the current source also. If there is a current source, okay,
Yes.
actually the current source is moving downwards. So what I'll
Yes.
do is I'll
Current
mark
source
my current.
absorbing the power.
Yes, the direction of sign I will write it like this.
Okay.
So we know by KVL, right? Potential increase will be equal to potential drop. Only if the
Yes.
sign is like this potential increase will be V. So minus V will be equal to 0, right?
Yes.
So this sign is clear, right? Why you're marking the sign like this?
Yes, ma'am.
Yeah. Now, is the power delivered or absorbed? There is
Delivered,
a
ma'am.
voltage source. The current is coming out, so it is power delivered.
Delivered.
Now,
Yes.
is the power absorbed or delivered?
Delivered.
Yes. From the positive terminal, if the current is coming out, then it is delivered.
Okay.
Into the positive terminal, if the current is entering, then it is absorbed, right?
Absorbed by the resistance. Yes.
Yes. In the same way, what about here? The current is entering the positive terminal.
Negative terminal.
The current is entering the positive terminal, no?
Okay. Entering from negative. Yes.
So it is power absorbed or delivered.
Delivered.
How? See, plus minus V. Is the current entering the positive terminal or not?
Entering from positive terminal. Yes.
Right? These are same, right? Is this and this one same? Because
Yes.
the arrow head is at positive, right?
Yes.
Okay. Now
Here.
tell me, this is absorbed or delivered?
Deliver.
How will it be observed? It is entering the positive terminal. No, just now for resistor you told. If the current is entering the positive terminal, it is absorbed.
Yes. Because it is a resistance, na, ma'am. It always draw the power, so it
Yeah.
absorb. But
Current
in
source?
current source, it confusing. Then voltage source and current source, because the current source is much powerful than the voltage source.
No. That depends on the values also, right? It depends
Yes.
on the value, the direction in which the current is flowing, then whether the voltage is dropping or if it is
Yes.
giving rise to the potential increase, right?
Yes.
So you have to, and as we saw, no, in VI characteristics of a current source. How will be the VI characteristics of current source?
Current source.
It will be like this, right?
It yes parallel to the voltage source.
If it is 5 amperes, I is equal to 5 amperes. So only in the first quadrant and the third quadrant, power will be positive. That is, power will be
Positive
absorbed.
absorb.
Here also power will be absorbed. here and here power will be delivered.
Okay.
So this current source can act as a delivering source also, or it can observe also. Okay.
Yes.
So just because it is a current source, you can't tell it is observing power, it is delivering power. There are also, if there is a chargeable current source, then during that time it is observing power. So it depends on the direction of the
And
symbol of the.
values of the current. Yes.
Yes. The simple thing to remember is whatever the component it is, there will be a plus terminal and negative terminal. If the current is leaving out of the positive terminal, then it is power delivered.
Okay.
There is a positive negative terminal. If the current is entering the positive, the sign is important. You shouldn't see, because see,
When
this is
entering
a
from positive and leaving from
positive
negative,
terminal.
then it is
Yes.
absorbing the
Absorbing.
power.
Exactly. Then you have to go and see in the question whether it is observing or delivering both matches, then it is positive. If it is not matching, then it is a negative value you have to put.
Okay.
Right?
Okay.
So there is one more question now. Okay, yeah. This is 5 ampere, 5 ampere. This is 1 kilo ohm. What is the voltage drop across the 1 kilo ohm?
Five volts.
5 kilovolts.
Yeah, sorry, this is 5 milliampere.
So 5.
5
5
volts,
volts.
right? Because
Yes.
the current flowing through the resistor is still 5 ampere.
5 amperes. Yes.
Then. So these are some common mistakes people usually make while writing the exam. What is the current flowing here?
Ten milliamps.
Yes.
Current,
it's
ma'am?
Yes. 10 by 1K, so it is 10 milliampere.
10 milliampere. Yes.
Because the voltage across here is just 10
Same.
mils.
Same, because they are parallel. So
Mm.
voltage same, current increases, voltage same.
Is this circuit valid?
No, ma'am, because the voltage increase is equals to voltage decrease, so there is been zero voltage
Yes.
across.
So this is not a valid circuit. Because here the
Yes.
potential drop
Equals
is
to
actually
potential.
20, not equal to 0.
Yes.
Right, yeah. Then what is the current I1? What is the formula?
Milliamp.
If this is R1, R2, then it will be R.
2.5.
Yes.
Yes, 2.5. Because the
So,
voltage across the both resistors are same. Voltage, current across the both are same.
This is current division rule. Then there is another one, voltage division rule. 5 volts, 2 ohms, 2 ohms. What is the voltage at this point?
2.5.
Yeah, it is 2.5 volts. Because it is R2 divided by R1 plus R2
Plus R2. Yes.
into
Into
V.
V.
So while you're doing superposition principle, this current division rule and voltage division rule will help you simplify the circuit to a great extent. So please remember these rules. Yeah. That's all. So today we have seen about the superposition principle, voltage division rule, current division rule, and basic simple circuits. Then we also saw about the power convention, right?
Yes.
So yeah. So we'll see in the next revision session about the remaining topics.
And
So if you
can you
guys,
little bit up, little bit scroll up?
yeah, this one.
Yeah, okay. Once.
So anyway, my
Okay.
sessions will be shared, right? Like
Yes.
live notes.
No, ma'am. In front of me, I'm writing that notes. That's why.
Okay, okay. Yeah,
Okay. Thank you, ma'am.
yeah. And also, if you have any doubts, please post it in the G space.
Okay.
Any doubt with the practice assignment, activity assignment?
And ma'am, in this quiz too,
Mm.
which week content cover? Week 4 to 8 or from week 1 to 8?
Week 5 to 8. 5,
5 to
6,
8.
7. Mm-mm.
Okay. And in end term, it will be from